All right, welcome to Module 4, Topic B, Lesson 11. By the end of this lesson, you're going to be able to represent proportional relationships in a table, get an equation, and then take that and actually graph it. You'll know you're successful today when you can take a word problem, create a proportional table of values, find the constant, create an equation, and then graph that equation and then apply that to other situations. Today we're going to do some examples, some exercises. We'll close out this lesson and then do our exit ticket. All right, so right now we're just going to kind of build off of what we did yesterday. I'm going to go ahead and make my 3 boxes because I'm going to be close reading. Pauline mows a lawn at a constant rate. Suppose she mows a 35 square foot lawn in 2.5 minutes. What area in square feet can she mow in 10 minutes? T minutes? So I mark my first box because I've read for the big idea. The second time I read, I'm going to be finding the ratio that they give us, okay? So the two numbers that they're comparing that we're going to use to find the rate. It says Pauline mows a lawn at a constant rate. Suppose she mows a 35 square foot lawn in 2.5 minutes. So these are the numbers that I'm going to be using for my rate real quick. I just want to identify which one's independent and which one's the dependent variable. I know time is always independent. So this minutes, this is my x variable, okay? And that means that how much she's mowing, how many square feet she's mowing is dependent on how long she mows. So this is my y variable, okay? And then the question goes on to ask how many feet can she mow in 10 minutes and then in t minutes. All right, done with my second read. This time I'm going to actually add these things into my table when I read, all right? Pauline mows a lawn at a constant rate. Suppose she mows a 35 square foot lawn. So that's my y. So I'm going to put this over here, 35 square feet. And they've already made my little label, so that's kind of nice. In 2.5 minutes. So in the corresponding row, in my x column, I'm going to put 2.5. And then I'm trying to figure out what area in square feet she can mow in 10 minutes. So this is what I'm trying to figure out. If this is a 10, what's this? Okay? It then goes on to ask me if this is a t, so if we just use our variable, what would this be? Okay? We're also just going to fill out random parts of this towards the bottom with whatever we need, but I'm done with my reading, so I can go ahead and get started on this. So the first thing I want to do is find my constant of proportionality. I want to figure out what's going on right here. To go from x to y, what am I multiplying by? And if I go from y to x, what am I dividing by? So to find that out, we're going to do y divided by x, right? So our constant equals y divided by x. So in this case, it's going to be 35 divided by 2.5. And when I work that out in my calculator, I get 14. So my constant of proportionality is 14. Okay? If I go this way, I'm multiplying by 14. If I go this way, I'm dividing by 14. So how could I write my equation? Well, I could say that to get to y, so y is going to equal whatever x is times 14. So this is my equation. Y equals 14x, right? Because y over here equals 14 times x. So I'm going to do this for each row. So this time I'm going to do y equals 14. What's my x value on this column? 10. 14 times 10 is 140. So in 10 minutes, sorry, they're mowing the grass outside. So in 10 minutes, Pauline can mow 140 square feet. It then goes on and says, what about t minutes? So I know that y equals 14 times whatever t is. So however much time you have, you just multiply it by 14. That'll tell you how many square feet you could do. So let's say I did 1 minute. So I do my y equals 14 times 1. So I could do 14 square feet in 1 minute. Maybe I did 5 minutes. I would do 14 times, oops, I did 5, 15. I would do 14 times 5, which is 70. All right, so I've made my table of values. I've got my answers. Here is my answer for the first part. How much time in t minutes is this one right here? I would just write my whole equation. All right, so now I'm going to actually graph these values. So remember that when we graph coordinate pairs with our x value first and then our y value second. X tells us how far to go over. Y tells us how far to go up or down, right? If it's negative, we're going to be going down or to the left. If it's positive, we're going to be going to the right or up. Think of number lines. All right, so I have my first coordinate pair is 2.5 and 35. It's the first one they give us. So I'm going to go over 2.5, which is about right here, and I'm going to go up 35, which is right here. So this is my first point. My next two values were 10 and 140. Now, I can't go over 10 because this only goes to 7, so I'm not going to graph this one. All right? I can't do the one with the t and the y because those are just variables, they're not numbers, so I'm going to go down to my 1 and my 14. So I'm going to go over 1, up 14, so it's going to be right about here. And then I have 5 and 70. I'm going to go over 5, up 70. There's no 70 here. But I have two values, so I can go ahead and make my line. I'm just going to get something like a straight edge so that I can draw it. It's going to go like that. And that is my graph. All right, so I've gone ahead and I've already close read this. Almost. I have one more read to do. So it says, water flows at a constant rate out of a faucet. Suppose the volume of water that comes out in 3 minutes, so that's the first part of my ratio, and its time, so that's my independent variable x, is 10.5 gallons. So that's my second number in my ratio, and that's my dependent variable, that's y. The question says, how many gallons of water would come out of the faucet in t minutes? So I'm trying to write an equation in terms of t. So I'm going to go ahead and fill in what I know in my table. And what's interesting is that they've already kind of created some lines and rows for me, so I'm just going to add a line at the bottom, a row at the bottom, sorry. So I have 3 minutes, oh no, they already have that, 3 minutes and 10.5 gallons. So I've just added in what they've told me so far. Remember, this is my x, this is my y, and I'm done with my close reading. I'm now just going to create my equation. All right. So I know that I need to figure out what is my constant, or what is my slope, that's what we're going to start calling it, that gets me from x to y. So I'm just going to use my formula, which is m equals y divided by x. So in this case, the row that I have with both numbers that I can use to find this is down here. So what they gave me to begin with. So I'm going to do m equals 10.5 divided by 3. And if I do that in my calculator, 10.5 divided by 3, I get 3.5. So this is my slope, this is my constant, and I'm going to use this for every row of my table, right? And I'm just going to put it in here so that you can see it. So if I want to go from x to y, I just need to be multiplying by 3.5. So for the number 0, to get y, I'm going to do y equals 3.5 times x. In this case, it's 3.5 times 0. So in 0 minutes, how many gallons does she, or that flow out of this faucet? Well, anything times 0 is 0, so 0. And that makes sense, right? If the faucet's not been turned on for any minutes, then no water is going to flow out of it. Next, we're going to do 1. So y is going to equal 3.5, my m, times, in this case, my x is a 1. So what's anything times 1? It's just itself. So in 1 minute, 3.5 gallons flow out of this faucet. Okay, now we're going to do 2. 3.5 times 2. 3.5 times 2 is 7. So in 2 minutes, 7 gallons flow out. And this is the original relationship they gave us, so it's already answered, but I'm just going to write the equation. It was y equals 3.5 times 3, and that gives us 10.5. And then the last row here is y equals 3.5 times 4, which is going to be 14. All right, so I've filled out my table, but I still haven't answered their question. It says how many gallons of water come out of the faucet in t minutes? So if this was just a t, what would I write for my equation? Well, if my x value was a t, I would just say that y equals 3.5 times t. And I can't really get it any more simplified than that. I can't solve that problem because there's 2 variables. So that is going to be my answer. So in t minutes, it's going to do whatever t times 3.5 is. All right. Now we're going to take these ordered pairs and we're going to graph them. So the first one I have in my table, I have 0 on my x, 0 on my y. So I'm going to graph this. This is my origin right here. Next, I have 1 on my x, 3.5 on my y. So I'm going to go over 1, up 3.5, right in the middle there. Next, I have 2, 7. So I'm going to go over 2, up 7. Always go over first and then up. Then I have 3, 10.5. So I'm going to go over 3, up 10.5. And then my last one here, I'm going to go over 4, up 14. Now, as you can see, this line, when I draw the line through it, is straight. And what that means is that this is linear, which also means this has a constant rate of proportionality. The slope of this line stays the same. It's not like all wiggly or anything, right? It is a straight line. And we could have known that from looking at our equation because we can see that our equation is linear because there's no exponents attached to our variable. Okay, we're done with example 2. All right, so just like on the last example, I've already done some close reading here. It says Juan types at a constant rate. He can type a full page, so 1 full page of text in 3.5 minutes. And I already identified those 2 numbers as my dependent and independent variables. Remember, time is always independent, so that's always going to be my x. We want to know how many pages, p, one can type after t minutes. Okay? So I'm going to go ahead and start filling this table out based on what they gave me. So they said 1 full page in 3.5 minutes. So I don't have a 3.5 minutes on my x column. So I'm going to add this in at the bottom. So 3.5. And in 3.5 minutes, he can type 1 page. So if that's the case, you know that anything less than 3.5 minutes, it's not going to be a full page. Anything more than 3.5 minutes, it's probably going to be more than a full page. I'm going to mark my third box. I'm done close reading, and I'm now going to use this row to find my constant of proportionality. So remember that m equals my y divided by my x. So in this case, my m, or my slope, is going to equal 1 divided by 3.5, which comes out to, when I do this in my calculator, 1 divided by 3.5 is a decimal that is very long, 0.28571429. I'm going to round this out to 0.29. Okay? So the equation that I'm going to be using for this is that y equals whatever x is times 0.29. So that is my equation for this problem. And for this bottom one, what did I do? 0.29 times? Oh, times 3.5, because that was my x. I'm going to write this linear equation at the top so I know what to follow this whole time. All right, so starting with my first row, I'm going to do y equals 0.29 times, what's my x? 0. What's anything times 0? 0. So in 0 minutes, he reads he types 0 pages. Okay, next row, I'm going to do y equals 0.29. This time my x value is a 5. Times 5. I'm going to do this in my calculator. And I get 1.45. So he reads like almost 1.5 pages, not quite, but a little bit less than that. All right, next one, I'm going to do y equals 0.29 times my x value, which is 10. So anything times 10, we just move the decimal place over once. So this is 2.9 pages. So he reads almost 3 pages in 10 minutes. Next row, I have y equals 0.29 times my x over here is 15. 0.29 times 15 in my calculator gives me 4.35. And then the last one they give me here is 20. I'm going to do y equals 0.29 times 20 in my calculator. And I get 5.8. So I filled out my table, but I'm going to need to answer this question that at the top I boxed in red. So that's the first question they give me. How many pages can one type after t minutes? So we know that y equals 0.29 times x. But in this case, they're wanting us to use p for our y value and t for our x value. So instead of saying y equals 0.29x, I'm going to say p equals 0.29. Instead of saying x, I'm going to say t. And they're just telling me to use different variables so that the p kind of shows you, oh, that's pages and that's time. Okay, so the number of pages equals 0.29 times time. All right, next thing I'm going to do is graph these numbers. So I'm starting off with my first coordinate pair, 0, 0. Next I have 5, 1.45. 5, 1.45 is going to be like right at 1.5. Then I have 10, 2.9. So I'm going to go over 10, up 2.9, so it's going to be right beneath the 3. And I have 15, 4.35. Over 15, up 4.35, going to be a little bit over 4. Then I have 20 and 5.8. Over 20, up 5.8, so pretty close to 6. And then the last one was the one that I did originally, was 3.5 and 1, so over 3.5, up 1, so it's exactly on this line. All right, and this is my proportional relationship. I can draw a line through it and create my graph. A little bit below it, but it's okay. So I have graphed my equation. I can see my equation is linear, which means it has a constant rate. The slope is the same. And then we have this question at the bottom. It says, about how long, and keyword about, I'm just kind of guessing, would it take Juan to type a 5-page paper? So what I'm going to do is I'm going to go to 5 pages. It's right here. I just kind of boxed it out on accident. I was trying to circle it, but 5 pages is right here. What I'm going to do is I'm going to draw a line from 5 pages and see where is it going to hit on this line. Oh, it's going to hit right there. So wherever it hits, I'm going to drop straight down. And then I can kind of guess that, oh, well, it's going to take him about 19 minutes to write 5 pages. And I can explain just by saying, well, when I have 5 pages and I look at where that lands on my slope, because it's a constant rate, it's following the same slope, it's going to land and coordinate with the 19 for my minutes. Okay? And this is all we had to do for example 3. All right, exercise 1, I'm going to start it out with you and then you're going to finish it off. So Emily paints at a constant rate. She can paint 32 square feet in 5 minutes. So I'm going to go ahead and add this in my table. This is my rate. Minutes, that's my x. Square feet, that's my y. So 5 minutes, it's not in our table. 32 square feet. I'm going to go ahead and help you guys find the constants. So m equals y divided by x. In this case, my y is 32 and my x is 5. So my constant is going to be, let me do it in my calculator real quick. It's going to be 6.4. So my linear equation for this is going to be whatever y is going to equal is going to be 6.4 times x. Okay? I'm going to let you guys use that to fill out this table. And get this table filled out. And then I want you to go ahead and graph it. And I'll give you a couple minutes to do this before we go over the question part. All right, so at this point you can see that I've filled out my table. Please check your rows. For the first row you should have 0, 0. Second row you should have 1, 6.4. Third row you should have 2, 12.8. Fourth row you should have 3, 19.2. And fourth row you should have 4, 25.6. If you did something wrong, check your math because you're just multiplying each x value by 6.4 to get your y value. I went ahead and graphed them on my graph over to the right. Your slope should look the exact same as mine. It should be this pretty steep positive slope. The last thing I'm going to do with you right now, it says what area A, and we know that our A is the same as our y, in square feet can she paint in t minutes, and this is the same as our x. So instead of saying y equals 6.4x, it wants to just put it in terms of A and t. So my y is actually going to be my A, so it's going to be A equals 6.4, and instead of x, we're going to use the t that they told us to use. It's the same equation, it just wants us to use their variables. Okay? All right. Last part of this exercise, you were supposed to answer this question. It says about how many square feet can Emily paint in 2.5 minutes. So I'm going to go to the 2.5 minutes, which is right here, and I'm going to draw a line up. Okay, it hits right about there. I would say 2.5 minutes is right at about 14. It's a little bit lower, I think, but that's going to be my guesstimate. About 14 square feet. And how do I know? These values correspond with the slope. Of the graph. So that is how I know. All right, I'm going to give you a second to do your exercise number 2 on your own, and then we'll go over it together. All right, here's what I've done so far. I went ahead and close read my problem. I identified my x and y values, and from there, I was able to find my constant or my slope. Okay, my slope is 0.083 repeating, and keep in mind that 0.083 is not the same as 0.083 repeating. You have to put a lot of 3's in your calculator to get that number. Okay, from there I wrote my equation y equals 0.083x, and I went ahead and I just answered this question up here. I said, oh, that's the same as saying m equals 0.083t. And then I applied it. So the values I got were 0, 0, 32.5, 65, 97.5, and 120, and 10. So right now I'm going to go ahead and graph that off to the right. So here's what my graph looks like off to the right. You can see that it's a constant rate. And the question says Joseph's friend lives 4 miles away from him. About how long would it take him to walk to his friend's house? So I'm going to look at my miles, which are right here on my y-axis, and I'm going to go to the 4. And I'm going to draw my line, see where it hits. It hits right there. Find the corresponding time, and I'm going to answer that. It says 50, so I'm going to say about 50 minutes. And I know this because these values correspond. on my graph. All right, exercise 3, take a moment to do this before we go over it and check your work. So after taking some time to do that on your own, here is what I have come up with. So I identified my x and y variables, and from there I found my slope. I did y divided by x, so I did 80 divided by 2.5 and got 32. So this is my equation right here, y equals 32 times x. I applied that to all of these rows, and these are the values that I got. 0, 0. I'm going to graph that right here. 0.258, so 0.25 is about right here, and it's at 8. 0.5 and 16, right there. 0.75 and 24. And then lastly, I have 1 and 32. So this is my graph. I've graphed all of those pairs. Drawing my line through my graph, and now I'm going to answer this question. At the bottom it says the copy machine runs for 20 seconds and then jams. About how many copies were made before the jam occurred. So 20 seconds, I got to figure out how many minutes that is. So 20 seconds out of 60 seconds, that's going to be 1 minute. So I'm going to go ahead and turn this into a decimal because all of these numbers over here on my x-axis are decimals. So 20 out of 60 seconds, how many minutes is this? This is what I'm trying to figure out. So I'm going to do 20 divided by 60. I get 0.3 repeating. Okay, so at 0.33 minutes, how many copies were made? So I'm going to go to 0.3. It's going to be right around here. So I'm going to draw my line up. See where it hits. I'm going to say it's going to be right around 10 minutes. Oh, sorry, about 10 copies, my bad. So about 10 copies were made. How do I know? These values correspond in my graph. Okay, and I'm done with exercise 3. All right, just to kind of close out this lesson before you do this on your own, please make sure that you close read these questions, okay? When you close read, you're looking for your x and y variable. Once you have your x and y variable, you can find your constant by doing y divided by x, okay? And then once you have your constant, you can create your equation. Once you have your equation, you can apply that equation to every value in your table. And then once you have that, you can answer questions, okay? So this is what your exit ticket looks like. Don't worry, there is a graph in Classclick, so you'll be able to graph this so that you can answer this question at the bottom. Do your best. If you need to look back on the examples and exercises I did with you, please do that on your own time. But other than that, you are good to go. And we are done with lesson 11.